Hi everybody. Sorry this is a little raw. I'm doing this in my car as I'm running around the world, but I wanted to get this little review out for you. So let's say in this situation that the information that you're given is 21% of the population shows the dominant trait. So let's think about what that means. What that means is the individuals who show the dominant trait are P squared plus your 2PQ. So that population, those two different genotypes are going to show or be 21% of the population. So how does this information help us in building our Hardy-Weinberg? Well, let's think about then, if the equation is P squared plus 2PQ plus Q squared equal 1, and we know that P squared plus 2PQ are 21%, then we can take 100% minus 21, and what that tells us is that is going to tell us that Q squared is 79%. And that is the most important piece of data that we have figured out here. So when we take a look at our Hardy-Weinberg, what we're going to do is we're going to put 0.79 where we would put Q squared. The next thing that we're going to do is we're going to take this 0.79 and we are going to take the square root of it. So when we take the square root of 0.79 or the square root of Q squared to get Q, what we figure out is that Q equals 0.889. And we're going to put Q down there and also Q up here. So now we're going to start to use our other equation. We're going to use P plus Q equal 1. So if we know that Q is 0.889, we're going to take 1 minus 0.889 to give us P. So P equals 0.111. And we're going to also put P up here. So now that we've got this information here, the next thing that we can figure out is we can figure out P squared. And I'm going to take 0.11, bring it down, and 0.11 and bring it across. So thus I am timesing 0.11 times 0.11. That gives us 0.294. So P squared is 0.294. Now I can figure out my two missing boxes, or my PQ and my other PQ. These would be our 1, 2, or our 2 PQs. So on the outside boxes, you have P plus Q equal 1. And on the inside boxes, you have P squared plus your 2 PQs and your Q squared. The 4 of these should equal 1. Let's just double check our math again over here. P plus Q equal 1. If I take 0.111 and 0.889 and I add them together, I do indeed get 1. So I'm on a good track here. So now what I'm going to do is I'm going to take P times Q, 0.111 times 0.889, and I get 0.099. And excuse me, I have the wrong value in here. This is 0.012. Sorry, 0.012, not 0.284 or 294. 0.012. Sorry, that's small. Okay, and then my Q squared is 0.099. For my other PQ, sorry, for PQ, it's 0.099. For my other PQ, I'm going to take P down and Q across, and what I'm going to get is also 0.099. We're going to do our math by checking that P squared plus 2PQ plus Q squared equals 1. So when I take 0.79, 0.099, 0.099, and 0.012, I add them together, I do indeed get 1. P squared plus 2pq plus q squared equal 1. All right, so now we're up to interpreting all of this information and what does it mean. So I'm going to give you a series of questions. All right, so first off, what is q squared? When I go back to my Hardy-Weinberg Punnett square here, I can go back to q squared, 0.79 or 79%. I want them in allele frequency or percentage. So we're going to take this 0.79 and we're going to times it by 100 to get 79%. What is Q? Okay, I'm going to look here, Q here and Q here. My Q value is 0.889. Times that by 100%, and Q is 88.9%. What is P? I'm going to go over here to my P's on the outside. P is 0.111. Times that by 100%, and I get 11.1%. What is P squared? P squared is this box up here, and that is 0.012. I times that by 100%, and I get 1.2%. Now remember, 2PQ, I'm going to add these two together. So when I add my 2 PQs together, I get 1.98%. Let's look at question number 7. What is the frequency? Frequency means percentage of the recessive allele in the population. The recessive allele in the population, what is that? That is Q. And so now we're going to go back to Q here, and my Q is 88.9%. Number 8, what percent of the population shows the dominant trait? Oh, that was what we started with. 21% of the population shows the dominant trait. So it tells me right here, 21%. The other thing that I know is when I come back up to my Hardy-Weinberg Punnett square, I know that P squared and my 2 PQs, those together are going to equal 21%. Okay, what is P? P, I just go back here and I look at my value for P is 0.111, which is 11.1%. What is the frequency of the dominant allele? The dominant allele. The dominant allele is also P. So these two questions are exactly the same answer. What percent of the population are heterozygous? So again, you're looking at your 0.099. Oh, I made a mistake on my math. So that's going to give us, sorry, this is not, your 2PQ is 19.8%. Sorry, again, doing this in the car. So this question number 6, 2PQ, what percent of the population are heterozygous, is also 2PQ. And so that answer was 19.8%. And again, 19.8%. What is the frequency of the recessive trait in the population? That is Q squared. And that is 79%. Q squared, 79%. What is the frequency of the homozygous dominant trait? The homozygous dominant trait is P squared. So we're back up here to 1.2%. And what is Q? Q is 0.889 or 88.9%. All right, so just a little review there. Enjoy. Bye.